Assalamu alaikum wa rahmatullahi wa barakatuh. Peace be upon you all and welcome to the channel. In this video, we will cover the second half of class or class T class. I honestly do not know how to label it at this point. But we will cover different methods that will grant us access to the metadata of a class. I should note that metadata related to methods, fields, constructors, modifiers, packages, and so on and so forth will be covered in their own respective lectures for simplicity. For this lecture, I will simply focus on the metadata of the class itself, such as the name of the class, the superclass if it has any, if it has a subclass. These are all metadata. And as we mentioned before, Java reflection basically involves the manipulation of the metadata of the code. This is considered data. The author or the person who wrote this code would be considered metadata, as in information about that data. But before we begin, Bismillah ar-Rahman ar-Rahim, Alhamdulillahi Rabbil Alameen, Wassalatu wassalamu ala ashraf al-anbiya'i wal-mursaleen, Sayyidina Muhammad wa ala alihi wa sahbihi wa man tabi'ahum bi ihsanin ila yawmiddin, warda Allahumma anna ma'ahum ajma'in, Allahumma amin. اللهم صل على محمد وعلى آل محمد كما صليت على إبراهيم وعلى آل إبراهيم وبارك على محمد وعلى آل محمد كما باركت على إبراهيم وعلى آل إبراهيم في العالمين إنك حميد مجيد. We begin in the name of Allah, the most merciful in this life and in the hereafter. We thank Him for all of His blessings that He has bestowed upon us, for they are innumerable. And we pray that we follow in the footsteps of Prophet Muhammad, peace be upon him, and his fellow companions. Amen. We also ask for prayers and blessings to be bestowed upon Prophet Muhammad, peace be upon him, and his family, as they were bestowed upon Prophet Ibrahim, peace be upon him, and his family. Okay, so we have seen a portion of metadata in the previous lecture through getName, but we will discuss it again for the sake of comprehension. And we will cover the common methods. We will not cover all of the methods, particularly since the API is vast and infinite. And to be quite honest, you would only need to be aware of Java reflection if, for example, you are designing a framework for Java, or perhaps you are designing an IDE, or even during testing if you wish to manipulate certain private fields or private methods. You can invoke them directly through Java reflection. If you try to invoke them regularly or programmatically, you would have an error because they are private. However, with the Java reflection, you can overcome these hindrances. Okay, so let us cover some methods. Let us start with so firstly, I will design two classes, a superclass and a subclass. Person. And then I will create student, which will be an extension of person or a subclass of person. Then I will create the object here. I will call it C1 in case I will need to use more. Probably not, but we will see. Class, like so. Okay, and I will open the source code for class in case we need to return to it for reference. Okay, so firstly let us cover the class name. I wish to obtain the metadata for the class name. What are the methods available? So we have getName. We also have getCanonical Name, which is a strange nomenclature. We can check that. Anything else here with name in it? Package name, no, we will leave that for packages. So that is all a Boolean. Okay, so perhaps we can check here. Get name, anything with name in it. Get name, get type name. Okay, so there is that. For name, we already took that. Okay, you know what? We will start with get name. Get name, which we have used before. There we go, and I will yeah, this is get name, and I will use the rendered view. This is beautiful. Okay, so let us print the name of this class, c1.getName, and let us see what prints. We have student. Perfect. Now if we return here, let us read about this. Returns the name of the entity, whatever it is, represented by this class object, which is in this case the student class. If this class object represents a class or interface, not an array class, then if the class or interface is not hidden, we will cover hidden classes possibly in the far future, God willing. Then the binary name, I wonder what happens if I click on this. Let me... Oh, this is a link, okay. Okay, it is part of class loaders, so that is, yeah, that is to be expected, because class loaders use binary files. Then the binary name of the class or interface is returned. If the class or interface is hidden, then the result is a string of the form n plus suffix, where n is the binary name indicated by the class file, passed to the lookup. Okay, let us avoid all of this because this is related to hidden classes, which we have not covered yet. If this class object represents an array class, then the result is a string consisting of one or more square brackets representing the depth of the array nesting. Here the depth refers to the number of dimensions, and I will show you an example in a bit, followed by the element type as encoded using the following table. We also have here, if this class object represents a primitive type or void, then the result is a string with the same spelling as the Java language keyword, which corresponds to the primitive type or void. Okay, so that is a lot to cover. Firstly, let us return to this one here. As you can see, it printed only student because this is the default package, so it does not present you with the package name. So custom class default package. But what if we try a class that is in a different package, such as the string class? String.class. So the default package, as you can see, does not have anything. Do not know why I have these up there. It does not have a package name, so it is empty. But the string class has a package name, which is java.lang. So you have the folder called Java, then the folder called lang, also known as the subpackage, then string, like so. Just call it default package, different package. System.out.println c2.getName. Let us see what is printed out here. As you can see, it prints the name of the package as well. So this will be java.lang dot string. Okay, well, what about this encoding that it spoke of? This only applies if you have an array. Oh, sorry, this. If you have an array, then it represents this, followed by an encoding to inform you of the data type of the elements within this array. Let us test it. So we will not test all of them. We can test int, Boolean, and a class type, simply to see the differences in encoding. Okay. But before we test the arrays, actually let us test this since it is easy. Let us test a primitive type. As C3 int dot class, like so. So here will be reference types. Here will be primitive type. C3 dot get name. Oops, I pressed Ctrl A by accident. And as you can see, it prints the Java keyword. This only applies if it is a primitive type or void. It will return the Java language keyword, emphasis on keyword. So it will not return integer, it will return int, which is a keyword in Java. If we change this to Boolean, it will return the keyword Boolean, and so on and so forth, as you can see here. Okay, so I will return it to int. Now let us cover array type, which is a reference type, of course. Oh yeah, I'll have to create another one here. Class C4. Let us say an array of strings, and I will also create an array of primitive, int and Boolean, simply to see the different encoding. C5 and why am I typing? C6 Boolean. Okay. So I will remove these from compilation, so we only focus on the output here. However, I will be a smooth criminal and copy these. So we have C4, C5, and C6. 5 and 6. Okay, let us test this and see. Okay, so do you see these letters? These letters represent the encoding here. Z represents a Boolean, I represents an int, and L represents a class or interface with binary name N. And here is the binary name, java.lang.string. This character, as you have seen written here, if I can find it, represents that this is a class array or an array type. Sorry, I have to take this phone call. I will be right back. Apologies for that. I have returned. So, as we were mentioning, this character represents that the class or the metadata of this class is referring to an array. This encoding refers to the data type of that array, and the binary name, if it has a binary name, which in this scenario it does, because it is an object or a reference data type, as opposed to the primitive data types, which do not have anything but the encoding itself. How about we test the nests or the depth of the array nests? Okay. Let us create another array type, C7. Let us go with double. And we will create a 4-dimensional array. And here, no, I want to copy this one. There we go, C7. Okay. So I will remove these from, or actually I will leave them for reference. Okay. Now let us return here. Firstly, we have the encoding, which is D, refers to double. Here. Then count with me. 1, 2, 3, 4 square brackets. This informs us that this array type has 4 dimensions. An array of an array of an array of an array of double. That is basically what it is informing us of. Granted, I wish they added the second closing square bracket, but beggars cannot be choosers, unfortunately. So we will have to manage. So this represents the number of dimensions in an array, and you will see that they match perfectly. 4 dimensions, 4 single square brackets. So we have obtained the name of the class through getName. So probably name this portion as getName. Let us see if there are other methods by which we can obtain the name of the class. So this will be, well, I know of this method, so I am cheating at the moment. Canonical name. This is another method. So let us test it with the same classes that we have here. So what I will do is I will copy these and I will paste them here. Remove this, remove this, remove these, and remove this. And here I will simply add get. I will show you in the IntelliSense menu. Get canonical name. As you can see, it returns a string as well, but it returns particularly the canonical name. We will discuss what the canonical name is. I have a separate lecture designed for the fully qualified name and the canonical name, which I will create later. I thought it would be best if we discuss it here now, then discuss it later, mention it here first, then discuss it later, bi'ithnillah and God willing. Okay. Then I will mute these, if you would like to consider it as such. Let us see what this prints. Again, print student. So it seems that the canonical name is the same as getName, but there must be a difference. Take note of binary name here for the getName method. What about the canonical name? Returns the canonical name. We will discuss what the canonical name means in this scenario, but it returns null if a class does not have a canonical name. Which classes do not have a canonical name? Local classes, anonymous classes, and hidden classes. Or if you create an array of a particular data type that does not have a canonical name, then that array type will also return null as a canonical name. So as you can see, the difference here is that this does not return the binary name, but rather returns the canonical name. So let us test this and see what else do we have. So this, this returns student. Let us see what this prints. string. So they are the same so far. Well, what about this? Int, again the same. And the array types. Here is the difference now. The difference between getName and canonical name appear in certain contexts or certain scenarios. With the array type, it does not present you with the single square bracket and an encoding, but rather it presents you with the getName, so the name of the class, whether it is reference or primitive, and it also prints the number of dimensions in the array. So as you can see here up above, we have one dimension, it prints one dimension, one dimension, one dimension, one dimension, one dimension, and here it printed all 4 dimensions. So the output here is slightly different. Personally, I would prefer to use the canonical name for array types as opposed to getName for array types, but that is my personal preference. Again, this would depend on what you wish to do with your code. Okay, so we have seen the differences here. Okay. And I will paste, okay, never mind then. There is another method. Again, I know this because I know this beforehand. It is called getSimpleName. GetSimpleName. So we will return to this in a moment. So what I will do is another bullet point, getSimpleName method, and I will copy this and paste it here. Okay, and I will remove this, and I will return this to compilation, change this to getSimpleName, like so. Then I will copy this, paste it here, here, here. This is going to be a long day for you because we are still in the name of the classes. We did not cover anything else yet. Okay, so let us test this and see what is printed. GetSimpleName, again, student is student. Well, what about string, which is in a different package? See the difference here? It did not return with the package name, it only returned with the class name. So simple name can be used for decorative purposes. If you do not wish to display your output with the package name, you can use the simple name. Well, what about the primitive type? Let us see. Again, the same as before. I feel sorry for the primitive types. No one seems to care about it. Let us check the array types now. The same as the canonical name. So I would recommend, but this is my personal preference, simple name for displaying an output rather than getName or even getCanonical name. Okay, how about, is there another method that we can use to get, we have here getTypeName, and it also returns a string. this one right here. And so this is, what is it, the fourth method? Yeah, the fourth method that we can use. And I will copy these. There we go. I am sorry, I just I remember there's a stupid song in America known, I do not know its name, but I know the chorus where the singer whines about being alone again, naturally. And I just told myself, you know what? For us as Muslims, you can easily marry. But in America, people are always alone even when they have, I do not even want to call them boyfriends, girlfriends, or partners. I think they are just there as, okay, you know what? No need to push it. I will just say romantic interests. And yet they are still sad, possibly even on antidepressants. And it does not make me wonder why. I know why, but it makes me happy to be a Muslim, to be quite honest. Yeah, subhanallah. That means praise Allah, but not truly praise Allah. There are other intricacies to it, but because English is a poor language as opposed to Arabic, it is difficult to translate precisely. Okay, now let us return to get type name. And I will start pasting it here. And one more time. Celebrate and dance so free. Music's got me feeling so free. Oh, sorry. That is just my illusions kicking in. Okay. Get type name. Return an informative string for the name of this class or interface. Let us see how informative it actually is. Okay, so we will return this to compilation and execute. Student, the same as before. What about a class from a different package? So it still returns the canonical name. lang.string. Okay. What about the primitive data type? How informative would it be? Again, not as informative as I was hoping. And what about the array types? Okay. Again, the same as before. So here we covered differences between get type name, get simple name, get name, and get canonical name. Now for you to actually see what is it that I am searching for? For you to actually see differences, we will have to create a complex example. But to avoid prolonging this lecture any further, what I would have decided to do is that I will reserve a lecture for this complex example to show you the different forms we can use these different methods for. So that would include anonymous inner classes, and so on and so forth. That way you can have a clear image of the actual differences between these various methods. So for now we will just end the names or the class names at this part, and I will create an addendum for this lecture bi'idhnillah and God willing, simply to show you the different forms or the different outputs that you can receive from the different types. Okay. Let us see what else do we have access to. So C1 dot. Okay. as subclass. This seems interesting. As subclass, and I will click it here like so. Instead of having to search through it, this would be easier. Okay. From the name, you can possibly deduce that this is related to child classes. So as you can see, you will expect a type parameter here, and it returns a class that extends U. So basically it returns the subclass of U, whatever you pass here, which is the argument here. And seriously, class, this is this is humiliating. This is painful to look at. Simply because the word class is a reserved keyword does not mean you should. This is disappointing. This is truly disappointing. You could have just said class object instead of class. Anyways, disappointment aside, let us see what this method accomplishes. Oh wait, there's a sneeze. Hold on. Do not leave. Do not leave. It left. Casts this class object, which is in this case C1 would be class student. Just hover up here, or whichever class is invoking the method, to represent a subclass of the class represented by the specified class object. So basically what you pass here is casted, as in transformed, to its subclass. Let us test this. So I will push this downward since we finished it. That way we have access to these classes here and it is easier for you to see. Subclass casting or retrieval, either or. Push this downwards. So, okay. C1 dot as subclass. We created a parent class here, person. Let us see what happens and when I pass it here. Person dot class. So this should be transformed into its subclass. And that should be the output here. Let us test it. Bismillah ar-Rahman ar-Rahim. And as you can see, it presents us with class student. Well, what if I pass in class student? Let us see what is retrieved. That means it does not have a subclass. If the class itself is the return value, that means the class does not have a subclass. But since we passed person class here, I can create a person class object as well. C8 person class, but either or is fine. So you can pass in this or you can pass in this, as we covered in the first lecture. They are both the same. So this will return class student. Okay. So the output here will be class student. I would also like to put this, just for your reference, to remember that both are exactly the same. There we go. Now I'll remove these from compilation because they are no longer needed, and push these downwards to see what else we can use. C1 dot, let us see. Get classes. This sounds interesting. Let us check this method. Okay, scroll upwards. Take note of the return type. It returns a class object, but in the form of an array. So we have to store the return type or the return value in an array of classes. Returns an array containing class objects representing all the public classes and interfaces that are members of the class represented by this class object, which is the one that is calling it. What does it mean by classes and interfaces that are members? It means inner classes or inner interfaces that we covered before. This also includes public class and interface members inherited from superclasses. Okay, so let us test this. Since we do not have inner classes, firstly let us test this to see if we do have inner classes or not. So we can say public inner class types or members retrieval includes inherited inner members. Okay. So what I will do is I will create an array and I will call this object C9 array. Or possibly just C array, or even classes array. This is more descriptive. C1 dot get classes, which is class student. As you can see, it has nothing. And then let us print the array in an enhanced for loop because it is easier and faster. Okay, let us see. So the data type would be this array counter classes array. System.out.println array counter or array iterator. Actually, I will change this to iterator because it is more descriptive since we covered iterators already. Okay, now let us print this. Nothing, because it has nothing. Okay, now let us add inner classes. Let us add a class and an interface. So we will add class called book as an example, and an interface called exam. Now let us print this again and see what is the output. Oh, did I add it to student? Yes, I did. Okay. So classes array, yep. Okay. Huh, this is odd. Okay. Let me just test something. And then this is truly strange. Let me return here. Oh, I know what the issue is. It is only public. That is the issue. I thought you needed to, because I remember you do not need a block for that. Come on, come on, come on. Oh, public, like so. So this should work now, bi'idhnillah and God willing. Bismillah ar-Rahman ar-Rahim. There we go. Now, this output presents us, and that is why I felt it would be best to create the lecture for examples that highlight the differences between different class name accessibility, just to highlight such icons. This icon or this symbol, the $, Of course, capitalism is everywhere, but anyways, this $ represents, or rather indicates, that the class before it contains an inner class which comes after it. So the syntax is outer class, $, inner class or inner interface, but I tend to use them interchangeably. But I should say class type, because a class type involves class and interface. So you have the outer class, the $. This $ indicates that there is an inner class or an inner interface, and there is the name. Also student, book. And it shows you the type, the class type of the inner member, not the outer. Because the outer will always be a class. But the inner book here is a class, and this inner member is an interface. So remember firstly to create them as public, not package, because this is package, so it is not detected by that method. And also remember in the output, remember this symbol, the $. When you see this output, it means that there is an inner member or an inner class type. This is the outer, what is to the left of the $, and this is the inner class member or class type on the right hand side of the $. Okay, let us test inheritance as well, and thankfully we have a superclass here, so course, just for simplicity. Okay, now let us test this and see what is printed now. It also factored in the inherited inner class. However, it highlighted the parent class from which the inner class was inherited. So this is the parent class of student. Course is present in person, but since student is a subclass of person, it automatically and implicitly inherits everything within person. Unless you override, that is a different story. But as you can see here, when it showed course, it did not show the subclass, but rather the parent class. So what does that tell you? This output can be informative for you if you use the subclass to print inner classes and you see a different name in the outer class. You can safely deduce that this is a superclass of this, provided of course you use the object of the subclass, not the object of the superclass, that is. And that is it for get classes, nothing more. At least I do not believe so. This method returns an array of length 0 if this class, of course, if it has nothing. Also returns 0 if this class object represents a primitive type, an array class, or void. Yeah, so it only takes reference classes or interfaces. Okay, perfect. We do not need this anymore. Well, you may be wondering, well, Muhammad or Sheath, however you wish to label me. I do have a reason why I use the pseudonym Sheath, though. You can probably deduce it from the avatar or the logo. Anyways, well, this targets only public inner classes. Is there a method by which you can overcome that and collect or display all classes or all class types with various access specifiers? Let us declare, there. let us check this method now, declared classes. Returns an array of class objects reflecting blah 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 blah. This includes public, protected, default or the package, and private classes and interfaces, but excludes inherited classes and interfaces. So this method is exactly the same as this method. The only difference is it overcomes this, but sadly cannot include this. That is the difference. So let us define it here as inner class types or members retrieval. And I did not specify public here because it detects everything. But here it excludes inherited inner members. Okay. So let us keep this class and change one of these to private. Okay, let us create a third one and have it protected. Actually, let us create a total of 4. Private, public, protected, and package or default, also known as package private. What should I call you? Stationary. T. There we go. Is it within... oh, no, I want the... typo. Okay, so found it. There we go. And finally we will say protected. What else do we have as students? Grades. Sorry, class. There. Okay. So we will use the Zahi way all the way, but with declared classes, of course. And we will return these to compilation. Now let us see what is printed. Okay, so as you can see, it printed all 4 class types that we have designated or declared here. But what is missing? This is missing. Why? Because this method, where is it? This method excludes inherited inner members. So it does not show you, it does not highlight if there is a superclass to this object class or not. So that is a disadvantage to using this method, and it is the advantage of using this method. And also, just to remind you, here is the symbol or the icon that indicates inner class types. Here is the outer class to the left hand side, and here is the inner class type on the right hand side, and its type is presented to you here. Perfect. Why is this? Why is the indentation strange here? Do not know. Okay, let us check what other methods we have available. This is enticing. Okay. Get modifiers, we will cover that later. Get interfaces, we will cover that later. Package name, blah blah blah. Simple name with okay. Get superclass. I would assume that get superclass as in get the superclass of the object. And it returns class super capture of this. So whatever this is, return the super of it. But let us check the documentation just to be safe. Oh, it is a native method, so we will not see its implementation. Again, you can see this is which bound. That is your quiz for today. But as you can see, this is the return type. And native methods do not have implementation. They are the same as abstract methods. But that is where the similarities end. Returns the class representing the direct superclass, not the indirect. So it will not retrieve the grandparent class, the direct parent class of the entity, represented by this class, which is the object that you call the method with. If this class represents either the object class, an interface, a primitive type, or void, then null is returned. If this class object represents an array class, then the class object representing the object class is returned. Enough reading, let us test it. So what can we call this? Direct superclass or parent class retrieval. And by direct, it avoids grandparents. So if you have this is a child of another class and you use the student object, it will return person directly. It will not return the grandparent of student. So let us print this and see what we have. C1, so we will use student class again, just to see if it will return person. Get super class, and let us test it. Bismillah ar-Rahman ar-Rahim, class person, perfect. Since it returns a class, I can use getName on it too. So we can use method chaining, get simple name, for example. And there you have it. So this will output class person. This will output just person. And of course you can use the canonical name and the type name and so on and so forth. Okay. Well, what about the array? Let us test it with an array. C4, which is the string array. Get super class. As you can see, it returned the parent of string, which is object, because remember, every single object in Java is a child of object, whether it is direct or indirect. But string is a direct descendant, as you can see here, but it does not indicate that it is an array. So this will be class Java or java.lang.object. Let us test it with a primitive value, C3. Oh, sorry. .get superclass. This should not return anything. Null, as expected. Perfect. Bye bye, baby balloon. Okay. Oops. What else do we have available for methods? Especially since I have to leave soon, so we can finish this quickly. Okay, so I believe we have the Boolean what is the word I'm searching for? Boolean functions. But before we cover Booleans, let us cover toString, simply because it is a method. So we will cover the toString method, c1.toString, and of course this is redundant with the newer updates. So let us see what is presented here, and we covered this in the previous lecture, but I thought for the sake of comprehension I would simply cover the toString method as well. toString method, and if you recall, it has a nested ternary operator, which I need to create a lecture for, بإذن الله and God willing. But as you can see, if it is an interface, it prints an interface. If it is a primitive, it prints empty. And if it is a class, it prints a class. So let us create okay, so let us test this with a primitive. So C3, this should be empty according to the toString method. Okay, perhaps I did not read it correctly. Plus get name, never mind. Yeah, so the empty part is here. This is the empty part before int. And let us test it with an interface. So let us create a new one here. Which interface should we take up? Let us design our own Java interface, and I will call this one drawable. There. And this will be drawable.class South C9. Okay. This should state interface and then the name of the interface. So this is interface drawable. This is simply int, and this is class. Class student. Yep. Okay. So this is the toString method. Quite simple. Alhamdulillah. And thank God. Oh, my back. There we go. Okay. Let us see. What else do we have? Oh, yeah, the Booleans. But before we tackle the Booleans, there was a method that captured my eye. This one. I want to see what this is. Oh, so it creates a new array. We will cover this with the constructors lecture, bi'idhnillah and God willing. This is how you can instantiate an object without using the new keyword or a constructor. So this is an advantage to using the reflective API. Returns a class for an array type whose component type is described by this class. So it returns a class. Returns a class for an... Okay, let us test it quickly. And since it is a return type, we can print it directly just to see what it... Array type. Okay, so it returns. Interesting. Okay, so let us test C4. Okay, so it adds this part, class array, and then adds the data type of that. Okay, so what can we call this? Returns a class for an array type whose component type is described by this class. Okay, so it creates a new array, as you can see here, and then gets its class. So we can say array type class retrieval, like so. And we will use C1 here. So basically what you can think of, or rather how you can visualize this method, basically it creates a new array from the data type that you passed, and once it creates this array, it obtains the class of that array. Hence why when we passed the string array, it actually created another dimension. So it created a two-dimensional array, and so on and so forth. But it does not just convert. In addition to the conversion, it also obtains the class of that array. So it is not technically a conversion per se, especially since the length is 0. Okay, I believe that is it. Now let us tackle the Boolean methods, and those should be quite simple بإذن and God willing. C1 is okay. Is array, is annotation, is enum, is hidden, is anonymous class, is instance, is interface, is local class, is member class, is primitive, is record. You can deduce from these names the following: that the Boolean methods are used to detect if the object class is an array, or is an annotation, or is an enum, or is an anonymous class, is an instance, and so on and so forth, and is interface. So we can call this section class object verification, type verification. Verification. Well, no need for the object because we can see it is an object. So let us print c1.isArray. Now you can deduce the output of this method, since this is not an array, so this should yield yes. If you answered false, you are correct. But what if I pass C4 instead? Let us test it. C4 is array. True. Perfect. Okay. Array type. And here we can check for primitive type. C1.isPrimitive. This will obviously be false because this is a reference type. So let us test it. False because this is a reference data type, not a primitive. But let us test it with C3 now. C3. True, because it is an int. Okay. Now what else do we have? We have interface type. South.c1.is interface. Is C1 an interface? No. Student is a class, not an interface. So this should be false. Perfect. What about the drawable class that we created? This is an interface, so this should be, oh sorry, not C2, C9 actually. So this should be true. Perfect. Okay. We will leave C1.is. We will leave this for now because we still did not cover annotations yet. So we will leave this for now. We covered records. Let us record type is record. That is false, of course, because it is a class, not a record. Because it does not spin you right round, baby, right round. Oh man, I crack myself up. Okay. Let us create a record and we will call it database. And then here, class C10 is equal to database.class. Now let us check if this is a record, and it should be true. True. Perfect. How about the enum type? We covered enums, thankfully, alhamdulillah. Student is not an enum, so C1.isEnum, where is it? this one. This should be false because it is not an enum or an enum. How about we actually create an enum and we will call it names. Then we will assign it here C11, and this will be names.class. So how about this? This should be true, while this is false. Perfect. Okay. What else can we use with the ises? Anonymous class, instance, local class, and member class. So this can be considered a nested class type. Let us refer to it as such. C1.is anonymous. This of course will be false because C1 is not anonymous. What about if C1 is where was it? A local class, and is member class. There was a, what did I see in the is that I wanted to check? Is instance, so we can test that in a bit. Now let us run these. False, false, false. Because C1 is not an inner class at all, nor is it an anonymous class. It is actually an outer class. But can we test this to see if we can access this, for example? Let us try it. So C1 dot okay, let us see. Oh, sorry, just give me a moment. I have to answer this. I will be right back. Okay, I apologize for that. I seem to be quite popular today. I have returned. Okay, now let us test if we can use a check to see if this would be, if we can use these here and test them. So let us instantiate an object from this member class. So what we need to do is create an object from the student class. So s is equal to new student. Then we call the outer class dot the inner class grades. The name of the inner class object, so I will call it G, is equal to the object of the outer class dot new the constructor of the inner class. Okay, so what I can do here is test. So it will be G dot get class, this one, get class. Then after that, dot is member class. I will disable these for clarity, and I will also test to see if this is a local class. We covered what local classes are. They must be within blocks, except of course this main block. But we covered what the blocks are, so this should not be a local class, but it is a member class. So this should be true. This should be false. Let us test this. Perfect. And that is it with regards to this lecture. I hope this video was helpful and beneficial to you all. Just as a reminder, for the nomenclature of classes, I will create an addendum with different options. So we will see what an inherited class would appear in terms of the output, an inner class, an anonymous class, and so on and so forth. So this will be created as an addendum, simply to avoid prolonging this video any further. Now, I hope this lecture was helpful and beneficial to you all. Enjoy the rest of your day, everyone. Be safe, take care, and peace be upon you all. Wassalamu alaikum wa rahmatullahi wa barakatuh. اللهم صل على محمد وعلى آل محمد كما صليت على إبراهيم وعلى آل إبراهيم وبارك على محمد وعلى آل محمد كما باركت على إبراهيم وعلى آل إبراهيم في العالمين إنك حميد مجيد.